All right, we are in or starting cycle 2. Remember, there's 4 cycles total for the entire year, school year. We're doing the first 2 cycles in the first semester. We're going to finish cycle 1A right before Thanksgiving break, and then we'll finish cycle 2B right before we start winter break. Remember that at the end of the semester, it's a cumulative exam. So everything we've done so far will be on that exam. And then everything carries over to second semester for a final cumulative exam of everything we've done this entire year. So looking forward just a little bit, cycle 2A, which is what we're in right now, will have 1 summative. And then at the end of cycle 2B, there's no summative, it's the cumulative exam. So you really have 2 exams left, and then 2 more projects. Okay, so first one rule of thumb in college is that a student should spend 2 hours studying outside of class for every hour spent in class. And this is kind of per week. For example, it's recommended that a student study 6 hours outside of a class if the student is taking a 3 credit hour course. If you don't know anything about college credits, that's okay. It took me a while to figure them out when I was in college because nobody told me. So a 3 credit hour course means that you meet for approximately 3 hours during the week. So you might take just the class on maybe a Wednesday night, and it's almost a 3-hour class. I think sometimes they're actually like 2 hours and 45 minutes, but rounded up to 3. So you have like one huge 3-hour class. Or you could take the class Monday, Wednesday, and Friday, each for, it's actually 45 minutes usually, or 50 minutes. It's not actually 3 full hours, but again, they rounded. Or you can take a Tuesday, Thursday class for an hour and a half or 90 minutes each. So college has a lot of options for you. You can take the Monday, Wednesday, Friday class for 3 hours, a Tuesday, Thursday class for 3 hours, or just 1 class each week. And this is for a 3 credit hour course. There's 6 credit hour classes, and there's also 4 credit hour classes, meaning that you might meet a little bit more each week. If it's a 4 credit hour class, a lot of math classes are 4 credits, I know. It's sometimes sciences, sometimes Englishes, and that means you might meet Monday, Tuesday, Wednesday, and Thursday, and then get Friday off. You'd meet for about an hour each day, or you might meet Tuesdays and Thursdays for 2 hours each, or Monday, Wednesday for 2 hours each. That has really nothing to do with this problem, but just preparing you for next year when you start looking at college credit hours and you're like, I don't even know what this means. So looking at Ben's classes here, he's taking a history class, a statistics class, a psychology class, and an English class. Each class is 3 credit hours for a total of 12 credits during that semester, meaning that he's in class for 12 hours during the week, Monday through Friday, or maybe he goes Monday through Thursday, or maybe he's got like some really weird schedule that he picked, but Ben is sitting in class for 12 hours during the week. So based on that, if you're supposed to study for 2 hours outside of class for every credit hour spent in class, Ben should really be studying for 24 hours during the week outside of class. And then looking at Kate's schedule, hers is a little bit different. Notice Ben had 3 credit hours for each class. Well, Kate has a history class for 3 credits, a math class for 6 credits, a chemistry class for 4 credits, and an English class for 3 credits. So Kate has more credit hours. She's taking the same amount of classes, but she's taking 16 credit hours. So she's in class for 4 more hours during the week. Now, Kate is slacking a little bit and is not studying very much. She's studying like 1 hour for each credit hour. Okay, part A. Find the total average number of study hours per credit for each student. Are they meeting the college rule of thumb, which is studying 2 hours outside of class for every hour spent in class? So taking a look at Ben, we need to come up with a fraction, a part out of a whole. No, actually, Erase that. Okay, average number of study hours per credit. That means a fraction. Number of study hours per is a division bar, credit hours. So for Ben, we're going to go Ben. He studies for 21 hours per fraction bar. The number of credit hours he's taking, 12. So Ben is studying about 1.75 hours for each credit hour. So an hour and 3/4. And then for Kate, again, number of hours studied, 19, divided by each of her credit hours, which is 16. So Kate is studying 1.19 study hours, studying that many hours for each credit hour. Hopefully those answers kind of make sense. The wording is a little bit confusing, I think, now that I'm saying it out loud. Okay, so are Ben and Kate, are they actually meeting the college rule of thumb? No, neither one of them are actually studying 2 hours for each class. If they were, Ben would be studying for 24 hours and Kate would be studying for 32 hours outside of class. Don't let that scare you. I don't think I studied for 2 hours for every credit hour I had. That's a lot of studying. Okay. Part B, find the hours studied per credit hour for each course Ben takes. Average the 4 rates. Does this result match Ben's overall average in part A? Why or why not? Repeat this process with Kate's information. Okay, so what are we doing? Okay, find the hours studied per credit hour. Okay, so I think that's our fraction. The total number of credit hours per hour studied. Okay, so history. He studied for 6 hours. Hold on, scroll. Okay, Ben studied for 6 total hours out of his 3 credit hours. Okay, statistics, same thing. He studied for 6 hours out of the 3 credit hours. For psychology, he didn't study as much. He only studied 4 hours for the 3-hour class. And then for English, he studied for 5 hours in the 3-hour class. So breaking it down per class, Ben did meet the rule of thumb for history and statistics. He studied for 2 hours outside of class for every credit hour that he had. Psychology, a little less. English, not too bad. Okay, so then I'm going to average them together. So I'm going to show you on Desmos how to quickly average. I think I like this a lot better. Let me exit out of all this. Okay. I think I like it a little bit better. You could go 2 plus 2 plus 1.33 plus 1.7 or 1.67 divided by 4. But if you have a really long list of numbers that you're averaging together, I like to go to functions, stats, because this is statistics, and then mean is the same thing as average. So I'm going to hit mean. And then I'm going to type in those 4 numbers. 2, comma, 2, comma, 1.33, comma, 1.67. And that will leave me with, my average is 1.75. Okay. And then we're going to do the same thing for Kate. Okay. Number of, the hours studied per credit hour. Okay, so I'll write those in again. For history, she studied for 6 hours. It was a 3 credit hour class. Math, she studied for 6 hours. It was a 6 credit hour class. Chemistry, she studied for 4 hours, and it was a 4 credit hour class. English, she studied for 3 hours. It was a 3 credit class. Okay, so we divide. This one was really easy math. 6 divided by 3, 2. 6 divided by 6, 1, 1, 1. Okay, so then I'm going to do the same thing, and I'll walk you through the steps one more time. So functions, stats is already selected because I just did it. And then I'm going to hit mean, and then I go 2, comma, 1, comma, 1, comma, 1. Okay, and then so my average is 1.25. Okay, and that was looking at a I was more specific in part B than I was in part A. Part A, we found the overall average of the hours studied per credit hour. For part B, I took it a step further, and I did that process for each class that they took. And I can see Ben is following the rule of thumb for history and statistics. Kate is only following that rule for history. For math, chemistry, and English, she's only it's like a 1-to-1 ratio. She took a 6-hour class, she studied for 6 hours. Took a 4-hour chemistry class, she studied for 4 hours. So why is my average the same for Ben in part A and B? Why is my average different for Kate in part B than it was in part A? Okay. So the reason the averages are different is because Ben had the same number of credit hours for each subject. He took a 3-hour class for each of those subjects. Kate did not. She had a 6 credit hour math class and a 4 credit hour chemistry class. So hers was different. So the weight of that class is different than Ben's. It has more pull to it. All right. We're going to go deeper into that as we go on through this lesson. Okay. Weighted mean. I think this is something new to most of you. I'm sure you've done averages, but this one is weighted because some values carry more importance or more weight than others. To find the weighted mean, multiply each data value by its weight. Add up those values and divide by the total sum of the weights. And here's the little formula for you. It's not too little, it's kind of long actually. And then they actually abbreviate it using the summation tool, which is I think just or summation symbol. I think it's just a scary symbol. I don't like using it too often. But it makes the formula shorter. So, okay. They gave you an example, super basic. 3, 4, and 5 are your data values. The 3 carries twice as much weight as the other values, 4 and 5. So what do? I go 3 times 2 because it has twice as much weight as the others, and then 4 has a weight of 1, 5 has a weight of 1. It's just itself. The 3 is twice as much weight. And then on the denominator, the sum of the weights, 2 plus 1 plus 1. Okay, and I highlighted, I drew arrows for you. And there is my weighted mean. So 3.75. If you actually took the average of those, the average would be 4. So this weighted average does make a difference. There's more weight on the 3. That's why the mean is lower than just the average, which is 4. Okay, let's try it out in number 2. We'll work through that one together. So find the weighted mean of 15, 25, 100, and 250 if 15 carries 4 times as much weight as the other values. Okay, so the 15 carries 4 times as much, so 15 times 4. And then the other values just have a weight of 1. It's just themselves. So 25 times 1 plus 100 times 1 plus 250 times 1. And then we're going to divide that by the sum of the weights. So 4 plus 1 plus 1 plus 1. Okay, I highlighted, drew some arrows for you. And then I just typed that into my calculator, okay? Just like I see it, I'm not going to show you. That'll just take time. I think you can figure it out. So the weighted average is 62.1. Okay, we'll take the actual average just to see how it compares. So delete. So let's go 15, comma 25, comma 100, comma 2, comma 250. Okay, the actual average is 97.5. Why is it so different? Because this 15, a very low value, has a very high weight. It has the 4 times as much weight as the other values. It has 4 times as much importance as the other values. That's why the weighted mean is so much different than the actual regular mean. Okay, let's keep going on. You would typically see weighted averages or weighted means in grades. I think that if someone asked me, okay, when would you use this? I think grades would be the one where the first thing that pops to my mind. Homework is 10% of your grade. Quizzes, 10% of your grade. Midterm, 40% of your grade. Final exam, 40% of your grade. Why? Because your midterm and your final exam are important, okay? Carries a lot of weight. Homework, not so much, because most of you are just gonna copy off a friend in the class, okay? Quizzes, they're probably short, couple questions, not very long, 10%, not that important, okay? Midterm, lots of questions. Final exam, lots of questions. Wrapping up the entire semester, did you know what you were doing, okay? A lot of weight being given to those, okay? This is how you figure it out. You took the grade. This individual student, where are they getting the numbers from? Right here. They scored 85 points out of 90. So they had a 94.4% for homework. Quizzes, they scored a 70 out of 80. 87%. Okay. Midterm, 66%. Final exam, 63%. Okay. Not too shabby. But remember, midterm, they didn't do too shabby on homework and quizzes, but midterm and final exam, essentially they failed. They had a 66%, 63%. That's in college, that's an F. Okay, so let's find the weighted mean. So we're going to take the grade that they received, those were the percents, multiply it by the weight, 10%, 10%, 40%, 40%. Grade times the weight. Here we go. We find the sum for each of those columns. 10% plus 10% plus 40% plus 40% equals 100%. So everything's accounted for. And then the sum of that is 69.74. You would divide those two, since the weight equals 1. The 69.79 just kind of 6. And that's what the student would get in the class. Now, if the grade was just simply averaged, everything carries the same amount of weight as something else, the student would actually have a 77.7% in the class. But since we're putting so much weight on the midterm and the final exam that the student did not do very well in, that's why our weighted average is so much lower. Okay, another example on that. This one's dealing with money, how much people are getting paid. Let's go with this next one. Super exciting. It's about cats. So if you love cats, here's your example. Okay. The following data represents the ages and years of cats at a shelter. Find the average age of the cats. Instead of entering the values into your calculator separately, because this is such a long list of numbers, there's a ton of cats in the shelter, use the frequency of the ages to find the weighted mean. The table is provided to organize your work. So we have 1-year-old cats, 2-year-old cats, 3-year-old cats, 4-year-old cats, 5, 6, 8, 11, 15. So I'm going to plug in the ages. Okay, bam. Then the frequency, I'm going to count how many 1-year-old cats are there, how many 2-year-old cats are there, how many 3-year-old cats are there. Bam. Okay, now I'm going to go age times frequency. So 1 times 7, 2 times 3, 3 times 10. Work shown there. Okay, then I'm going to multiply them together. There we go. Okay, so then I'm going to add this last one. I'm going to add them up. Okay, so I'm going to go sum 40. I just added that whole column up. Next one, sum. Added them all up, 160. Now, to find the average, we divide those two numbers. We go 160 divided by 40 to find the average age of the cats. Average age of the cat is 4 years old. Okay, that was so thrilling, right? We also have median and mode to describe data. Median is the middle number. Mode is the most common value or values in a data set. I'm not going to go through that. You can read the chart yourself. Okay, why is this important? Well, some people look at the mean to describe the average. Some people look at the median to describe the data, to kind of to skew the data how they want it to look. So find the mean and median for the data set of ages of college students in a small study group. If a student who's 55 years old suddenly joins the group, how will that data value affect each measure of center? Okay, so we're going to first calculate the mean and the median for this set of data without the additional 55-year-old. So the mean is 20.5 years old. If you want me to go through that, I will. Otherwise, you can skip through all this. We'll delete all this. I'm just going to type in my numbers. Oh, actually, okay. Functions, stats, mean. Okay, I'm going to type in that data. 18, comma, 22, comma, 25, 24, 19, 20, 19, 17. Okay, 20 and a half years old. Now, to find the median, I actually need to list the numbers from least to greatest. However, we have Desmos, life-saving tool here. It's going to calculate it for us, okay? I deleted, what did I just do? I deleted the mean off of there. I'm going back to functions, and I'm going to hit median. I didn't type in any of the numbers, retype in any of the numbers. I just deleted mean, put in median, and it calculated the median for me, 19.5 years old. If you didn't like that, if you want to do the long route, go ahead. List them from least to greatest, find the middle number. Okay, now with the new student, we're going to add the 55-year-old student into our data set. So I'm going to delete median again. I'm going to retype in the mean. And then I'm just going to add in, I don't know how to get all the way over. I'm just going to comma 55. Now we added the 55-year-old in there. Okay, now the average is 24.3 years old. Okay, what's the median? Let's go back to the beginning, delete out the mean. Median is now 20 years old. Okay, so how did this 55-year-old affect the data measures of center for each group? So the original data versus the new data. Well, it really affected the mean a lot because you're adding in this large number, which increased the mean. If I'm looking at the actual age of the students, the first data set, 20 years old. Yeah, most of the students are a little bit younger than 20, a little bit older than 20. And with adding this 55-year-old, it raised the mean to 24 years old, which there's one 24-year-old, one 25-year-old. Everyone else is younger, so not a very good representation of majority of the students. Now the mean, not really affected because again, we're just looking at the center number. We don't really care what the actual values on the outsides are. We're really just concerned with the center number, okay? So that's why that one didn't change very much. It's all typed in there. You can pause the video, read through that if you want to. Moving on to number 5. Now we're looking at salaries for nurses in a clinic. Here the table shows all of their salaries. Okay, what is the mean salary? I'm going to use Desmos. This is a lot of numbers. I don't want to have to type all those, or I don't want to have to do a whole formula for that. Okay, so functions, mean. Let's type them all in. All right, so average salary is $57,580. Okay, median. Since they're kind of arranged from least to greatest, you could absolutely start crossing out bottom numbers, crossing out the top numbers until you eventually find the middle. Or you can just scroll all the way over. It'll take a minute since there's so many of them. And we'll erase the mean and we'll just type in the median and it'll figure it out for us. Is it faster hitting this over button a million times? I don't know. Totally up to you. So backspace, function, mean. The median, not mean. The median is $52,500. So part C, which is larger, the mean or the median? Why? Okay, hopefully you can tell which one's larger. It's the mean. Why? Because you have large values. You've got large salaries at the very top end of the pay scale that are pulling the average up. You have an individual making $100,000 and you have an individual making $125,000. When you have a good number of, half of your nurses are making $50,000 or less. So let's see if I erased that, typed the mean in again. Let me re-scroll all the way over. What would it look like if I took those top two salaries off? Bear with me while I scroll all the way over. And see what the average would be if we didn't include those two numbers. Okay, so delete those top two salaries off. Okay, if I deleted those top two salaries off, now I'm at $51,000. So that's $6,000 less than what we originally had. If I took off, maybe I took off the 70,000s. Okay, if I took off those couple, those three $70,000 plus salaries, now I'm at $54,000. Like, that's a pretty good representation of the center of my data here. Okay, so if the nurses were trying to make a case for raising salaries, which measure of center would the nurses want to use? Would they want to present maybe to the union committee, whoever they would need to talk to, the higher ups? What number would they want to represent? Would they want to show most nurses median salary or the mean salary, the average salary? They would want to use the median because it shows that they're making less. It's a little bit truer representation of majority of the nurses. Part E, what is the most common salary? What would account for this? Okay, well, there's three people making $31,200. Why? Probably because the clinic hired 3 nurses with the same level of education, same level years of experience. It is cumbersome to average all the data values at one time. Could you average each column and then average those results? Why or why not? Actually, we're just going to skip that one. I don't want to get into that. Okay, I think we covered everything we needed to cover for this. You've got 2 days to finish this, so hopefully take a break now, do the homework section tomorrow.